Hey guys, so I've been asked numerous times to make a YouTube tutorial series on how to use the Unreal Engine in general, how to get started, game design, game development, that whole category. I stream on Twitch a lot, especially with the game that I'm working on, and a lot of people have asked if I could kind of put some videos out there. So I figured I'd make this series to kind of show you guys a lot of pro tips that can help get you started. So if you're a little bit more advanced, you could probably skip further into my series or just pick the ones that you like. But today we're going to be talking about game theory in general and like the main practices you should be aware of, the things you should get down right the first time so that it makes your life easier later as you start to make your game. So the first thing we're going to talk about is organization. Um, Regarding organization, you need to have basically some form of note-taking software. For me personally, I use Trello. So Trello works really well for me. As you can see, I have a lot of notes here. Trello's free, so you don't have to pay for it. It's pretty much limitless, so you can just have as many notes as you want. You can put everything into categories. There's a ton of other software out there. I'm not saying you have to use Trello, but I use Trello for all of my main patch notes, bug reporting, things that I really need to know, like what do I have to fix. And there's like, you're just going to have to make notes. And if you're brand new to game design, if you don't have a note taking system, you're going to need one really bad because it's near impossible to remember everything that you're going to have to fix. And these lists are going to get huge and you're going to have to write them down somewhere. So, first things first, get yourself signed up with something like Trello.com and get yourself in the habit of taking notes. If I want to make a new note here, I can make a new checklist. I can do whatever I want. But the whole point is you can start getting into this system and figuring out how this works. I'm not going to get into it too much, but I'll just show you that you can also make charts, whether it's in Photoshop or however you want to do it, and then you can put the charts in here and you can talk about it. It really doesn't matter. However you want to do it, you can do it. And it works pretty clean. It's pretty smooth. You can have other people kind of help you with it as well. So if you're really thinking like of having friends help you, or there are other people on your team, you can assign them. You can give different members access to different cards, and they can check things off for you when they fix it or finish it or whatever. So Trello's just really nice. It's a good place to start. The next one is Obsidian. Obsidian is really a good tool. This is another free one. I use Obsidian like crazy, as you can see, for the game that I'm working on. It lets me storyboard everything and let me know where everything's supposed to go, how things are going to be organized. Especially for things like multiplayer, it helps with organizing, different systems. How am I going to interact with systems? Which systems talk to who, why, where, missions, anything you can possibly think of. Obsidian is a really good way to keep things organized. And you can obviously like put images in here to make it look a little bit more presentable for yourself, or however you want to do it, so you can kind of get a reminder of what means what. But long story short, that's pretty much the two major tools that I use to organize. So that's Trello and that's Obsidian. So, and then this is called the Canvas. So I just use the Canvas. I don't really use anything else in this. I just use the Canvas and make what I need to do. And it just helps me a lot to keep things organized and see like where on my flow I have to go in order to get things to work. Like for example, in my game, I have a system where you're in a home world, you load up your transport ship, and then you can load up vehicles in that transport ship, and then you can take them to an actual map, which is over here. And then they play the map, they harvest resources, they get rare resources, they get loot, and then that carries back to here, which goes to the loot inventory, goes back to the ship, goes back to missions and milestones for achievements and unlocks, and then it goes back to the homeworld inventory, and we're back to where we started. So it really helps with like organizing like the progression system on where you need to go. If you have to save things, if you got to sync with the Steam Cloud, where should that stuff take place? So it's really fundamental to make sure you guys get into things like Obsidian to help organize your general thought process. And that's what we're basically talking about in this first episode here is just how to get started, what are the correct procedures, and really, it's all about taking notes and organizing right off the bat. When we get into the actual Unreal Engine, um, honestly, the first thing you're going to notice is things are going to start to pile up really fast. And you're going to start bringing things in, whether it be assets or asset packs, or if you're trying to bring in something that works as a plugin, whatever. It doesn't matter what you're working on. The long story short is you have to keep things organized. So what I'm going to do is show you a few methods that help me stay organized with the game that I'm working on. As you can see in the lower left here, I have all of my folders and I have them named specifically for certain sections of the game. For example, we have assets, and then inside of assets, we have accessories, building, bullets, decorations, facilities, workstations, which mean different things for me. Those are personal terminologies that I've made. Volumes, vehicles, and you can change the color of folders just by right clicking, going up here to set color, and you can choose whatever colors you want. And yeah, it's pretty easy to start making folders to try to organize. Try to get in this habit of keeping things generally organized with a hierarchy, such as assets. And then within assets, you can have things that are literally assets. Or if you want, you can have one like this with blueprints. And I have all of my major blueprints in here, all of my data tables. And then within this, I have one called enums. And this is where I keep all of my general enums. And then another way to do things is to compartmentalize within that. Um, so what I'll do is, for example, let's say I'm getting an asset such as, let's do a landscaping asset here. So I have resource assets. These are specific resources that you can harvest in my game, such as this rock right here. And I'll show this in episode 2 of how we did that. But what you do is you basically just open this up, and then we have rock 1, you'd make rock 2, rock 3, rock 4, and you just go down the row. And then within that, you have all of the assets that are connected to that specific rock. So for example, you have the static mesh, you have the actual material instance, you have the icon, you have the textures that are used for it. That way it's all inclusive in just that folder. So if you ever have to change anything or anyone ever has to change anything with this rock, they can just go directly to that folder. They know exactly where it is and they can change it directly rather than not knowing where everything is. And maybe the static mesh is with a bunch of other static meshes or the textures are just in a big texture folder somewhere. So this helps keep everything really organized. This is pretty much the standard procedure for most AAA games when they're made. You want to try to compartmentalize everything with a good hierarchy such as this. Obviously, the naming will change. The correct terminology, Epic Games has a list on their site where you can find out what the correct footer and header are for all of your names, such as SM for static mesh, or T for texture, but I'm pretty loose and relaxed with that because it's just me working on my game. So as long as I am comfortable with it, then I'm good to go. And you're probably going to want to be the same way. Just make sure that when you are doing stuff, you keep things at least semi compartmental so that you're not going to go crazy later because I'll tell you right now, things get really crazy really fast. You can see, like, for my enemies, I then break them into factions or creatures. If we go into factions, I then have machines, humanoid. I'll have different types of factions here. And then creatures, I have different types of creatures. And then if I wanted to change, like, for example, the Ravager, I could go into the Ravager and anything to do with the Ravager is right here. So I can change this creature and this entity. I have all sorts of different things related to just him, his animation blueprint, which is also a child of a master animation blueprint. This is why we're going to talk about this in just a minute. And then I have the blueprint for him, which is also a child of the master enemy blueprint. So I will show you what I'm talking about that right now. Let's go back to the other example. Let's say we're in our buildings here and we have a new actor. So let's just make a new actor real quick. And we'll just call this building BP, let's say BP. Uh, we can call this master building. And then we would make this into a child. So here's how you properly start structuring major systems. So if I was going to have a building, I know I want buildings in the game. One thing I want to do is I want to make sure that I can right click this and then create a child from this like that. And we're going to call this BP building A, whatever. And the whole point of doing this type of a system is I'm in the buildings folder. I have the master, which is the main parent of all other children actors that I'm going to make for this specific thing. So now what that means is anytime I make adjustments to this master here, so if I pull this up, so this is what we're looking at inside our main. We can add a static mesh because we're going to need a static mesh, obviously. And now we have our main system here. We can make this a generic cube. We can give that a default material, something like this for now. Doesn't really matter. Sure, that looks good. Okay, so we have a cube, right? And this is our parent, our master. And then what that does is you can see the child automatically updated to the master. So now this will automatically do whatever this does, but we can make this one different. So now, for example, if I make another child and we call this one, let's say BP building B, okay, so if I put building A here and I put building B here, what we can do is we can make these both whatever we want. We can actually change the static mesh. So if I go into building A and I go into building B, when we open these up, let's make building B a different color. There it goes. Okay. And if I save that now, you'll see that these are both different. That's a semi-translucent material, but I'm just trying to hurry up and do something here just so you can see what I'm talking about. But so these are two different actors now, but they both share the same fundamental code that's in the master code here. So if we open up our master code and we take a look at this, all we're having is a static mesh here, okay, that we've added to this main parent class actor here. And the two children will follow and obey the main code of the parent right here. So if we move this over here, you can see it automatically adds it for us. It says on begin play, this is building B. On begin play, do what the parent does. Okay? So, okay, what does that mean? Well, that means that when this master fires off, this parent, whatever we code in this begin play, the others will do. So if we said print string, hello, and we saw it twice. So if we do print like that, then what we can do is we can just go over to building B. We can always click these off and do this if you want to get rid of the message, or you can just hit this little button here to get rid of the toggle message. It doesn't matter, but this is inherent. So this is basically saying that building B will now use all of the parent's code, and this is the parent right here. So whatever we code in here, it will do this first, okay? So for example, if I say parent message, okay? So now the actual master here will say parent message when I hit play, and so will the children, right? The both children set, because we only have two children in our scene right now. So you're just going to see two messages. So they both said what the parent says to say. However, here's where things get interesting. If I go to building A and we look at the event graph, this one actually says that it is not connected to the parent, but this one does. Sometimes this can happen depending on how you made it, how you set it up. If this ever happens and you need it to make sure that it's using the parent's code, all we can do is we can just right click it and say add call to parent function. That's it. And now this will automatically always do whatever the parent's doing. We don't have to worry about anything else. And it's pretty short and sweet. But if we want to change it, I'll show you that in just a second here. Okay, so now building A is going to use the parent's message. So it's going to say parent message. Building B is going to say parent's message because it's saying the same thing. Make sure you do the code that's inside the parent. But now we want building A to, after this happens, we want building A to say print string building A. And we want building B to say building B. So what's going to happen here is each child is going to fire off the parent's code first, which says parent, and then it's going to fire its own individual code later after it does that, which will say building B. And what this represents is it's saying I will do all the code that I'm programmed to do in the parent, such as find out which game mode this is, find out where my actors are coming from, whatever it may be. And then it will also do extra code like this. So if I hit play, you'll see in the top left, it says building A, happened really fast there, I'll do it again. The other one says building B, and both of them are saying parent message, which means they're both firing off the parent's message, and then they're firing off their own unique individual message. And that's the same thing for code. And the reason why I'm explaining this to you on day one is because this needs to take place in your head of how you want structures to work, how you want systems to work in your game. Okay? If we want to start making a game, we have to think ahead. Okay? And that's where note taking comes in. That's when we go back to things like this and we say to ourselves, okay, what is actually going to happen? Where are we going to go? What needs to take place? And when you start doing systems like this and organizing everything, it's going to help you later with things like this, with deciding, like, okay, we're going to have a master blueprint, and this is going to be the parent, and this will be for all things in the game that are buildings or structures that are going to, let's say, blow up, or they can be interacted with, or maybe these are all the items in the game, whatever it may be. And then we will make a child of those just so that these can inherit that, but they will do something different afterwards. So, for example, this blue one here, maybe I want this to, burst in flames when I click on it, and maybe this one needs to melt when I click on it. So if we want those two to be different, but we both want them to be clicked on, then we can have the master say, anytime I'm clicked on, do something. And then we can say, when that something happens, building B says, I want to melt, and building A says, I want to catch on fire. So we have two different systems, both using the same hierarchy from this system here. And this is the system that you want to use for almost everything in your game. And a lot of people do not talk about this, and that's why I wanted to bring this up on day one. It's incredibly important, guys. If you are making a game and you do not have proper hierarchy organization, you're going to suffer greatly later on. So I'm just going to break it down one more time and just explain it on this chart so that we can all kind of see it together for those who may still be a little confused about what's going on. So this is the parent or the master, whatever you want to call it. And then this one down here would be the child. And then this one be another child, okay? And these are variants, basically. All right, so these are basically, they inherit the same function from this parent, right? So this parent does the same code, the same starter code in both of these, but these are both different. So this one may be different than this one. And the reason why I say you want to set this up is because you want to say to yourself, if you're going to have a bunch of assets, this is the most optimized way to start creating your functional assets. If you just make, for example, building A that catches fire or whatever, like we said before, and then building B decides to melt, you still have to do the starter code inside both of these, and it's just redundant code, and it gets messy and it's unnecessary. So you always want things to have a hierarchy system when you design how you do things in Unreal Engine. If you don't have this, you will suffer and it will eat you alive later on. So you need to learn this. This is very important. This is AAA procedure. This is how you do it the correct way. So make sure that you start thinking about, okay, what kind of systems are going to be in my game? Well, we're going to have, let's say, let's change this to master enemy, okay? And then we'll change this to humanoid, and we'll change this to creature. Okay, you can see how this gets really crazy fast. And then the creature does, different types of AI. So we'll say the creature does stalking, hunting, like that. And then this one has different behaviors. The humanoid would obviously use a meta human skeleton. And it would also probably do, maybe let's just say, like patrols. So different types of AI are involved for that. Whereas this one wouldn't use a metahuman. This one would use, let's say, a custom skeleton that you would rig in Blender. So you got to start thinking to yourself, okay, so if I do that, now I can have out of this creature, we may have, let's say, a dog, we may have a cat, or let's make it different. Let's say it's a lion, and let's say this is a sheep, Okay, and you're going to see how this gets really crazy in a second. And this is how you design your system. And for example, the sheep is going to be what? Well, the sheep is going to be passive. Okay, the lion is going to be territorial, and we're going to have the dog be kind of, you know, uh, we could call it leashed. So it would have like a leashed AI, least aggressive or something like that. You could do it. You could also say like, make it like a turtle, whatever it is. I'm just trying to give you guys an example. So this one could be like extra slow and passive. So you're gonna have like all these different variations, and they're all gonna start breaking down and getting more and more complicated. You could even do this and say, out of so we have our main blueprint here. This is our main master enemy, or master whatever, our parent. And then you have the first child, which is the creature. And then out of that, you have more children that follow that main creature procedure. And then out of that one, you could say, out of maybe this isn't a lion, maybe this is hostile. Okay. And then this hostile breaks into more, such as bear, lion, cheetah, whatever. So you can start seeing where you need to have proper hierarchy and proper organization. So hopefully that helps you guys a little bit. Again, I highly recommend Obsidian. So get Obsidian, get Trello, get started with that, get familiar with it. I play with the canvas. There's like different modes over here, and I just mess around with the canvas, um, which is over here. You can just create a new canvas at the top. And it works really well for me. So, whatever works for you, I guess. If you find other software out there, that's perfectly fine, but you need to have some type of. The next thing you want to learn about is when you want to rename maps, because nobody's perfect. I mean, you can't just know what you're going to call something. Um, just duplicate it. Okay. It may take time if it's a big map, so be smart about this. But if I right click this and I say duplicate map, it will then let me make a dupe of it and rename it. And then I can delete the old one. Just make sure you update that name wherever you may have it in your game, because obviously it won't know where to find that if you change the name. It has to just have the same name. So if it's the same name, great. If it's something different, just make sure you update it accordingly. So it's just something to think about with maps, because I've heard some complaints about that. And I've had that happen to me as well, where I'm trying to make a map and then I want to rename it and then it just acts goofy. The other thing I'm going to show you, this is a really good tip. Again, we're just getting started, guys. This whole series is going to go deep into stuff that most people don't even tell you. So if I make changes, let's say I want to move assets from here to like here. I want to move assets. I want to move a blueprint somewhere, right? It doesn't matter what. Maybe I want to move this thing somewhere. Well, if you ever move anything from one folder to another folder, you must come up here to content, or the hierarchy main master folder, right click and say update redirector references. You must do this. Get in the habit of doing this. If you don't, what you can have happen is you can accidentally create a shadow version of that item, which means you'll move an item from folder A to folder B, and then the engine will think it's in two places at once. And if you start working on B, it won't notice that it's not there, so it will still do it to A. And then you'll think, oh, I don't need A anymore. So you'll delete A and you'll delete the entire thing, and B will disappear. So you'll basically delete everything. And if you didn't save it or have a backup, you can't go back. So please make sure you always right click that folder and choose update redirector references. You have to do this whenever you start moving things around. Some things will move automatically and you'll be like, oh, I didn't need to. It didn't do any changes. I'm fine. Who cares? Just get in the habit of doing it. It'll save you a lot of drama. Okay. And then the final thing I'm going to talk about today for proper procedure of getting set up and started with your game design is to back up everything. Back up everything. Okay. I'm going to show you what I'm talking about. So as you can see, I have different folders on a different hard drive that is for specifically just backing up my game. And those folders are dated. I just date them. And in each one, I include a build, which is a packaged version of the game. You don't have to do that. But the important one is this right here. You want to make sure that you have your actual game folder that has everything. So you go to your game, you hit the main folder that has everything in it, and you just back it up to a hard drive. I try to do this at least once or twice a month. Okay, you have to do this. I had many situations in my life where I've been working on stuff and, we lose it. We didn't have it backed up. What were we thinking? In most cases, I'm also a music producer, so I make music on the side, and I have all my music backed up on clouds because it's a lot easier to back up music, such as the Google Drive, the Dropbox. There's other services out there that you can use, um, or even just like a different computer somewhere, just in case something happens. But you need to make sure that when you're working on this game, these files are huge. You can see that this one is 65 gigabytes because this is the raw. This is the uncompressed raw. Plus, if you're including a build in there, that's an extra 7 to 10 gigs. So make sure you have a nice, big, healthy hard drive. It doesn't have to be an SSD, just something that just works well, and just back this stuff up. If you don't back it up, it will bite you in the ass. Sometimes things happen and you realize, oh, if I only had backed that up, I wouldn't have lost, 3 months of work. I would have lost just like 2 days. Especially if you're going to start moving big files around, if you're going to update to a new version of Unreal, please make sure you back your stuff up. Get in that habit. These are all super important things that nobody told me. I made horrible mistakes. So hopefully this video will help you guys not make the same mistakes that I made. So that's all I've got for this episode today. I am going to extend this series. It's going to go pretty far. And if you guys enjoy it, obviously thumb it up, help the algorithm so we can help more people see this video and learn the very important pro tips that, to be honest, most people don't even mention. And I'm going to be going through the entire series like this. I'll be telling you guys all the dirty little secrets that I've learned. And I think it's going to be a good series. So, all right, I'll catch you on the next one.